Hello everyone, I'm Paul and today we're solving problem 2537, count the number of good subarrays. So we are given an integer array, nums, and an integer k, and we want to return the number of good subarrays. So a good subarray is any subarray that has at least k pairs of equal numbers at different indexes. Okay, so this problem has two main parts. First, you need to know how to count subarrays, and second, you need to know how to implement sliding window. About the first one, we can see down here that the constraint says that nums.length is smaller or equal than 10 to the power 5. This means we cannot implement double for loop because that would require a time complexity of big O n square, and we need something faster. So what this means is we need to count subarrays efficiently. Okay, so now let's go with a few examples. Let's say we have this array with all ones and k is equal to 10. This means we need to count every subarray in this array which has 10 or more equal pairs. So let's see, we have one here, one here, one here, one here, another one here, another one here, another one here, this is another one, and this is another one, and this is another one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of equal numbers in this array. So the only subarray which includes 10 or more equal pairs is the original array, this one over here. So we can return 1. Now let's go with another example. Now for the solution, let's say we have this array here and k equals 2. First we will create a map which will store the count for every element in the array. We will also have an accumulated variable initially with 0, and this will store all the times we have seen the current number in previous indexes. And we will also have a result variable initially with 0, and this will store the count of good subarrays, meaning subarrays that have k or more equal pairs. Now we'll start here with 2 pointers. We'll create a left and a right pointer, and first we'll check how many times have we seen this 3 before. Well, the answer is 0. The map is empty, so we add to our accumulated values a 0, and we add to the map 3 equals 1. So now we have seen the 3 one time, and we update the right pointer. Now the right pointer is here at 1. We have never seen the 1 before, so we add 0 to the accumulated variable, and we add 1 equals 1 to the map and update the right pointer. Now right pointer is here at 4. We have never seen the 4 before, so 4 equals 1 in the map. Accumulated value stays at 0, and update the right pointer again. Now the right is here, and we have seen 3 before, one time actually, so we want to add to the accumulated values a 1, and we want to add to the 3 in the map a 1, so now we have seen the 3 2 times, and we update the right pointer again. Now right pointer is here at 2, and we have never seen the 2 before, so the accumulated stays the same, and we add 2 equals 1 here in the map and update the right pointer. Now we check if we have this 2 in the map, and we have it. We have seen the 2 one time, so we add 1 to the accumulated values. Now it's 2, and we add this 2 to the map. Now we have seen the 2 times, and now the accumulated value equals k, so this means we can start adding subarrays to our result. The question is, how many subarrays should we add here? And well, remember that a good subarray includes at least k equal pairs. So we know that this subarray is valid, and we also know that we could add any number to this array and it would still be valid. Okay, so here instead of 2 we could have 3 valid pairs, or 4, 5, 10, 15, whatever, and it will still be a valid array. So as we said, this is a valid array, but this one over here is also a valid array. So we can implement a small formula here, which is n minus right index, and this is the amount of subarrays that we want to add to the result every time our accumulated values are greater or equal to k. So in this case we have 7 elements in this array, and r is at index 5, so 7 minus 5 is 2, so here result equals 2. And once we have done this, we want to update the left pointer, and now we want to subtract a 3 from the map, so now we have seen the 3 one time, and we want to subtract the remaining 3's from the map, which is only 1, from our accumulated values. So this would be a 1 also. Now 1 is smaller than k, so we continue updating the right pointer and we check how many 4's do we have in our map. We have 1, so we add 1 here to the accumulated values, and we add a 4 to the map. Now we have seen the 4 2 times, and now accumulated values are equal to k. What this means is we can add subarrays to a result. How many subarrays do we want to add? Well, n minus the right pointer subarrays, so 7 minus 6 subarrays. So we want to add 1 subarray, and our result is 3. Now we update the left pointer over here and we subtract 1 from the map. Now we have seen the 1 0 times, and 2 is equal to k, so this means we can add more subarrays to the result. How many? Well, 7 minus the right pointer subarrays, which is 1, so 3 plus 1 equals 4, and we update the left pointer again and we subtract these 4 from the map. So now we have seen the 4 one time, and we want to subtract these 4 from the accumulated, so this now is 1, and 1 is smaller than k, so we continue and update the left pointer once again and subtract here from the 3. Now we have seen the 3 0 times, and the accumulated it's still 1, and 1 is smaller than k, so we continue. Now the left pointer is here and we need to subtract this from the map. So now we have seen the 2 one time, and we need to subtract remaining 2's from the accumulated. So now this is 0, 0 is smaller than k, so we continue. Now the left pointer is here in the last index, and we need to subtract this from the map. So now we have seen the 2 0 times. We need to subtract this 0 from the accumulated, which is still 0, and we continue, and that's it. Now we reach the end, and this is the result. Now the time complexity for the solution is big O of n, and space complexity is also big O of n. So now we'll go with the code and hopefully you will get the idea. First we start with n equals length of nums and scene equals a dictionary with int initially. So this means every value in the dictionary will be 0 by default. And the accumulated is 0, right is 0, result is 0. Now we'll say for left in range n, while the accumulated is smaller than k and we are in bounds, so right is smaller than n, we will add to the accumulated the value at sin nums right. Okay, and we want to add 1 to the map here, and we want to move right pointer, so right plus equal 1. And now we'll say if the accumulated is greater or equal to k, we will add to the result n minus right plus 1 subarrays. And now before updating the left pointer, we want to say sin of nums left minus equal 1 and accumulated minus equal the remaining values at sin nums left. Finally, we return the result, and this is the entire code, I believe. So let's see what happens. This is default dict int, so now this should work. Let's try again, and as you can see, this works. So now we'll go over with the math solution that you might find useful for future problems. Now let's say we have this array over here, and we are trying to find how many valid pairs do we have, meaning how many pairs of equal numbers do we have here. Well, this is the same as saying how many combinations of 2 equal elements do we have in these 5 equal elements. Okay, so this is the same as saying 5c2. So we need to find how many combinations of 2 do we have in 5. And for those who don't know, let's refresh the formula of combinations. NCR equals n factorial over r factorial times n minus r factorial. Remember, we are trying to find NC2, okay, because we are trying to find every pair of equal numbers. So we are trying to find 2 on n. So here we can put a 2, and here we can put a 2 also. So this would be the same as n factorial divided by 2 factorial times n minus 2 factorial. This is the same as saying n times n minus 1 times n minus 2 factorial over 2 factorial times n minus 2 factorial. So we can cancel this and this, and our final formula would be n times n minus 1 divided by 2. So with this formula we could get any combination of 2 in any valid array or subarray. Okay, now let's say we have this array in k equals 10. We'll start with the left pointer here and the right pointer here also at index 0. First, we don't have any pair, we just have a 1, so we will add 1 here to the map. Now we have seen the 1 one time, and we update the right pointer. Now r is here, and we add 1 to the 1, so now we have seen the 1 2 times. And here we need to add every pair between left and right. So every pair in an n equals 2. Okay, so this 2 comes from here, and this 2 is because we are looking for pairs, and this is equal to 1, so we add 1 here to the pairs. And given that the pairs are smaller than k, we update the right pointer. First, we want to remove from pairs n, c, 2. So the pairs that we had at the previous amount of ones. Okay, so we want to remove 2, c, 2 pairs. So now pairs is 0. And now we want to add this element to the map. So now we have seen the 1 3 times. And now we can add to the pairs 3c2, which is 3. Now pairs equals 3. And we update the right pointer. Now right is here, we have a 1 here. So we go to our map and we see that 1 is 3. This means we have to subtract from pairs 3c2. So we are subtracting this 3, and pairs is 0 again. Now we add 1 to our map. Now we have seen 4 ones, and we need to add to the pairs 4c2, which is 6. So this is now 6, and we update the right pointer here. And now we need to subtract from a universe of 4 every pair that we have already stored here. So this was 6. Now the pairs are 0, and we can add this one to the map. So now we have seen the 1 5 times, and once again we want to add 5c2 to the pairs. This is 10, so now we have 10 pairs, and 10 equals k. What this means is now we can add subarrays here. How many subarrays? Well, n minus r subarrays. So in this case, we are adding 1 subarray only. Now we want to update left. So we want to subtract these 10 pairs from our pairs. Now we have 0 pairs. And now we subtract 1 from the map. We have 4 ones. And now we update the left pointer. And now we add 4c2 to the pairs. So this was 6. 6 is smaller than k. And now we update the right pointer, and we end here. So this is the result. Now we will code this up, and hopefully you will get the idea. First we say n equals length nums, and sin equals default date initially with a 0. Result equals 0. Now we want to create our function nc2. This will take n as an argument, and inside here we will say if n is smaller than 2. This means if we don't have any pair yet, we return 0. Else we return n times n minus 1 divided by 2. This is the small formula that we saw previously. Now we will say pairs equals 0, left equals 0, and for right in range n. First we want to subtract from pairs the combinations for the current element. So pairs minus equal nc2 of sin nums right. And now we will add 1 to the map. So sin nums right plus equal 1. And now we want to add to the pairs the amount of pairs we can make for the current element with the updated map. So nc2 sin nums right, and here we will say while pairs is greater or equal to k, result plus equal n minus right. And here once again we want to subtract from pairs the number of combinations for the left element. Now we want to subtract 1 from the current element in the map. Sin nums left minus equal 1. And now we want to add to pairs the combinations for the updated element in left. So nc2 sin nums left. And finally we return the result. So this is the entire code. I think this is more difficult than the first solution, but if you learn this, you will be able to solve harder problems. So if you didn't get this part, I recommend you to go over the video again, or at least over the second half until you get the idea. So now I will submit this and let's see what happens. Here I was missing a colon, so let's fix this and try again. Now I got a time limit exceeded, so here I forgot to update the left pointer, left plus equal 1, and now it should work. And as you can see, this one also works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.